Okay. Hi, I'm Rich with Inside HPC. We're here at ISC 12 in Hamburg, and I'm at the ScaleMP booth. I'm here with Shai Fultheim, the CEO and founder of the company. So Shai, why don't we start at the beginning? Who is ScaleMP and who do you help?
Hi Rich, great to have you here again in Hamburg, every year. So ScaleMP provides virtualization solution for technical computing. Our virtual machines used by customers to create very large memory execution environment to allow it to run workloads such as bioinformatics workloads or manufacturing workloads that need hundreds of gigabytes or sometimes terabytes and terabytes of data. So we take multiple off-the-shelf industry standard servers, we put a virtualization engine on top of that, and we create from that a virtual machine that combine the capabilities of all these machines. You get hundreds of cores, terabytes of memory, and off you go to run your application.
So Shai, you guys had a big announcement this week, kind of a new twist on your software running on a different kind of architecture. Can you tell us more about that?
Yeah, in fact, that's pretty exciting. So what we've done with Intel in the last few months, we took vSMP Foundation and we ported that to the mic or Intel Xeon Phi.
Yep.
Now, what we do is we use the same virtualization engine that is used by our customers for software-based SMP, but now computer A is the host machine, computer B is mic, and computer C can be another mic. And from all of those, we create a software-based SMP with hundreds of cores driven by the host, driven by Xeon Phi, and sharing the same pool of memory. So from your perspective as a user, you get a shared memory machine, just a big shared memory machine, with hundreds of cores. Some come from the host, some come from the Phi, with the shared memory. Some come from the host, some come from the Phi, and you don't need to change anything. That means, take the Fortran code that worked for you for the last 20 years, just throw it there and it runs. You don't need to be coprocessor aware to run on such a solution.
In the past, ScaleMP helped me get a lot of memory, big memory jobs, right? How does this work? Is there a memory story, or is it a totally different kind of solution?
No, in fact, it's the same technology. For years, what we're providing customers is to run workloads without boundary. Servers create boundaries. You have a server, you have two sockets, so your boundary is the 16-core level. You have a server, you have 128 gig, that's your boundaries. When you use virtualization, you can create a virtual machine that have hundreds of cores and terabytes of memory. So that was the story all along. What we do now, we use that technology in order to take the boundary that sits between the host cores and the mic. While mic gives us many cores or many threads, it's independent, isolated system. It sits within the same box, but you need to move your code. You need to transfer the code to run on that or to run here. It's just like you work on a workstation and you send your code to the cluster in the back. So with the same technology of virtualizing two independent, isolated x86 entities, virtualizing to them one with unified context for all the cores on the memory, we now virtualize mic and the host as a single context, and we give the customers the same value. Lots of cores and lots of memory, transparently, not being aware to the way they are connected or positioned in the data set.
Well, congratulations on that. Anything else going on? What else is new at ScaleMP? Anything you want to share?
Company is growing. We recently won a very large system in Daresbury Labs, UK. They will be able to create shared memory systems that are very large, all the way up to from resources that are 6,000 cores and 48 terabytes of memory. Now, I do not expect a single workload to run on such a resource, but being able as a scientist in the scientific community in the United Kingdom to be able to get yourself resources of that size, that's pretty large. And I hope that we will see lots of science contribution and science created from these machines, because at the end of the day, that's what the story is all about.